So today we are going to discuss about the signal degradation in optical fibers. So we will discuss what is the cause behind the signal degradation when the signal travel from transmitter end to receiver end. So there will be two questions in your mind. There may be two questions in your mind that what are the loss or signal attenuation mechanism? So what are the reason behind, what are the cause for the loss or signal attenuation? And second question is why and to what degree optical signal get distorted as they propagate down the fiber. So these are the two main questions which will be answered at the end of this PPT. Basically, signal attenuation while propagation of optical signal through optical fiber. So is determine the maximum repeaterless separation between the optical transmitter and the receiver. So when we are transmitting any optical signal from the transmitter end to the receiver end, then what will be the loss in the signal strength? That is known as the signal attenuation. So this is very important parameter in determining the maximum distance between the transmitter and the receiver, or we can say inline amplifier. Signal distortion. So signal attenuation or signal power is measured at the transmitter and receiver end, and the difference between that two gives the idea about the signal attenuation. So signal distortion cause optical pulses to broaden as they travel along the fiber. Their width get broadened and they overlap. There is a overlapping between the neighboring pulses. And this will create the errors in the receiver output, and in turn will result in the limitation of information carrying capacity of the fiber. So signal distortion results in the reduction or decrease in the information carrying capacity of the fiber. So how will you measure the power loss along a fiber? So as the light travel along the fiber, its power decreases with the distance exponentially. So if P0 is the power here, P0 is the power at the origin and Pz is the power at a distance L. Then the power loss is given by, then the power at this point, Z point, is given by P0 e to power minus alpha P Z. Here alpha P is the fiber attenuation coefficient and its unit is Naples per kilometer. And in so this is the basic unit of fiber attenuation, but in if we want to calculate in dB per kilometer, then it will be calculated as alpha is equal to 10 by L log P0 by L is equal to, when we solve this numerical value, then we will get 4.343 alpha P 1 kilometer. So this is the alpha dB per kilometer. It means this is the fiber attenuation coefficient in dB per kilometer. And this 3.1 is also formula. This Pz is equal to P0 e to power minus alpha Pz is also used to calculate the power loss along the fiber. But it gives the result in Naples per kilometer. Here it will give the results in dB per kilometer. So this is a conversion, few more conversion formulas, and you can calculate in milliwatt also. So this is basically the power calculation or power calculation, and based on the power calculation we determine the attenuation. Here you can see the optical fiber attenuation versus the wavelength. This is showing the attenuation in dB per kilometer and this is the Wavelength is given in the nanometers, and these are the different windows where the optical fiber communication is used. This is the first window where optical communication. This is second window where optical fiber communication is used. This is the third window where optical fiber communication is used. And as the wavelength increases, this is the graph of attenuation of the signal. So it is decreases as the wavelength is increases, and around 1400 nanometer attenuation is increased. And then after this 14, here it reach up to the peak, and after this attenuation again decreases. So this is the optical fiber attenuation versus wavelength.